Yeah, today we'll go with one more map which is called as HashMap. So HashMap is also one more class which is implementing the map interface. It is also used for storing key value pairs. Okay, so you can use this map also for storing if you want to store key value pair, you can do this. And let's look into the hierarchy of this. Okay, hierarchy is nothing very simple. Okay, HashMap is implementing which interface now? Map interface. So HashMap is implementing map interface. So this is the hierarchy here. So straight away we'll get into the examples now. Okay, so it's also used for storing key value pair, and as you know, these things now. These are some notes for HashMap. HashMap is implementing what? Map interface. HashMap can store what? Same key value pairs. HashMap uses hash table data structure for storing what? Its keys. Okay, like tree map was using what? Tree structure to store the keys. HashMap uses hash table to store the keys. When you see an example, you will clearly understand. But get the concept now. The concepts will be cleared with some examples. So the next concept, the keys will be unordered. Yes or no? In hash table, always what happens? The order is not guaranteed. So the keys will be unordered. The null keys are allowed here. Okay, null keys are allowed, which is not happening in tree map. Okay, so null keys and null values are allowed. Yes. So different type of keys are allowed. Even different type of keys are also allowed here. And duplicate values are allowed. And hash map is not synchronized. So let's see. But there is one important catching point here. What is that? What elements you add in hash map, or what elements you add as key in hash map, they should have the overridden hash code method. Hash code method is mandatory to be overridden for the keys here. Okay, that we'll see with an example itself. Are you clear these points now? So you're going to use keys now. It's very simple now. Whatever key you use, okay, that should have the overridden hash code method and equals method. Otherwise, you know the problems now. Searching will fail and duplicates will get inserted. So that's the reason. Okay, you should override hash code and equals. And luckily for us, what happens? Because we are using strings or integers, they have the overridden toString method. Yes, and you can see this now. I'm using string now as what? Key. So for it, what has happened? It is overriding hash code and equals method. So that's how it happens. Fine. So now create the object. Yes, once you create the object, you can start filling what? So here what happens? HashMap is equal to new HashMap. So let's look into the constructor of HashMap. I'm using the default constructor. What does the default constructor do? Let's see. Okay, see, the internet is not working. I'm just showing you the docs here itself, which has been downloaded. Yes, always keep a copy of this. If your internet is not available, you can always refer to this, because without the document you can't study anything here. Java.util, yes, and we are looking into what? The hash map. And once you are in the hash map, yes, it has got so many constructors. Yes, so many constructors are there. These many constructors are there. Okay, so once you have these many constructors, I am using this constructor. What does this constructor do? Initial capacity 16 means 16 buckets will be allocated, and fill-in ratio will be 0.75. Almost all same. What constructors you saw in hash set, linked asset, same constructors. Okay, so but only we are dealing with key value pair now. So hash map, this is the constructor we are using. So as soon as I create an object of that, what happens? Question is that, yes. So here what happens? Okay, so one hash table gets created first. One hash table with, as soon as I say this, and hash table with 16 elements will get created like this here. Capacity. This is the capacity. And what is this going to have? Okay, I think I have taken some. It will be having the hash code. I think I need space. 1 second. It will have the key, and it will have yes, 16 spaces will be there. 1, 2, 3, 4. So this is what happens now. Now you are filling the values now. Yes or no? So what is that? Yeah, this is the hash. Now see, when the hash. So this is which object now? Map object. In the map object you'll have 16 buckets like this. Now what am I doing? Put. See, in maximum, see, always in maps you work with two important methods, which is that put, get. So maximum you work with this only here. Put means if you want to put the elements you'll say put, and if you want to get the elements, get. Ulta will say. Understood? Sign. So customer map dot put. So I'm putting one string as the key here. So for that string, first which method is invoked? Hash code method is invoked. Okay, string will be having the overridden hash code now. So the hash code will be taken, means for this the hash code will be calculated. Supposingly the hash code of that is 7521, something like that I am taking. Understood? So 7521, that is the hash code of what? Kumar. Okay. So now the key will be put into this bucket. Okay. Along with the key I got the value now. What is the value? Double. So fine. 11.11. So this is the key and this is the value now. So that's how it's linked. Are you getting the idea? Understood. Next, I am adding which one? Ravi. For that again hash code method will be called. For Ravi string, hash code method will be called. So depending on that hash code, again what happens? It will insert it into some bucket. So we don't know. They have their own algorithm. So inside some bucket it will be putting now. What is that bucket? Okay, here supposingly for Ravi the hash code is 61981, something like this. So Ravi will be here, and what is the value for that? Is the key, and the value for that would be 22.22. Getting it now? Next, Amog 7916. So again key value now. Amog value is how much? 33.33. Then Vinay, okay, 8196. So Vinay will be here. Value for Vinay is 44.44. Then Balaji, okay fine, 8192. Balaji is the key, 55.55. So what did you understand from this concept now? So when you are adding your keys in HashMap, okay, so the hash code of the key will be used to store it in the hash table. Okay, next, I can put null keys. See this in HashMap. First we'll see the output once again. See the output now. I'll show you this and then I'll put the values. See, this is, I can add null key. I can add what? You understood this above concept. Now here what you have to understand is null key. Okay, I am adding null key. Then I can add what? Dissimilar key. Then I can add different type of value. Then I can add what? Null value. Then I can add what? Different value. So values can be dissimilar, okay, and they can be null, okay. And if you try to add a duplicate value, what happens? Yeah, this is duplicate value. Yes or no? It will insert duplicate value. But Sunil is different, key is different. Are you getting it now? See here. Just one second, I'll show you the output. It will become clear. Okay. The order is not guaranteed. So you got all the values. Null, Praveen, Balaji, Sunil, Kumar. Okay, Vinay, Amok, all these values are there. Understood? But yes, the concept what you have to understand from this example is, these things you understood, there is no problem with this. But the other things what you have to understand from HashMap are, you can add null keys, dissimilar key, dissimilar value, null value. Understood? These are the things what you have to understand. And one more thing, if you try to add a duplicate value, fine, it overwrites. Sorry, it is not overwriting. Okay, it is adding, you can add a duplicate value. I am not talking about updating. Okay, I am saying can add duplicate value. If I say Sunil, it's a new key, different key. So I can add what? Duplicate value. So now, see 44.44 will be there for Sunil also, 44.44 will be there for Vinay also. See this output. I'm sorry about that. So Vinay also is there, means Sunil also is there, which means that duplicate values are allowed. Duplicate values are allowed. So that's what you have to understand here. Yes, now we'll start seeing how it's getting stored in the HashMap. So yes, now I'm putting null key. So null also might have some hash code. Understood? Say 1921. So null. Generally null will be put in the first always. 10110, something like this. A key is null. Value is what? 66.66. So this is how it is linked. So then next I'm adding what? New integer. So it's a dissimilar key. Notice earlier what were your keys? What were your keys? Strings. But now what is the key I'm adding? Integer. So hash table allows what? Dissimilar data. So that's why it's allowing here also. So what happens now? New integer. So generally what is the hash code of integers, you know now? It will be the same. For 10 what is the hash code? 10 only. For 20 what is the hash code? 20 only, because they are returning the same value. Okay. So assume that it is 10, the hash code. So the key is 10 and what is the value? What is the value given? 99.99. So then next Praveen. For Praveen some other might be there, like something like 9127. Praveen is the key, value is Praveen. Then hello, yes, we can add null values also. 6598. And lastly Sunil, 8196. Sunil, what is the value? So here you can see a duplicate value, 44.44. 44.44 is duplicate. Clear? So I just showed you how it is getting inserted into the map. Clear? And now that's why, see, we can't guarantee the order here. When you are putting values in hash table, okay, we can't guarantee the order, because the values will be stored based on the hash code and their own algorithms they have got. So that's why the order is not guaranteed. Clear? Clear this? See, this is how it looks, your map. Clear? And as soon as you know the rule now, 75% of your map fills, 16 more will be allocated. For what purpose? For further manipulations. If you want to add and all, it will maintain 16 more extra buckets. So these slots, what you call this, you can call them as slots or you can call them as buckets. So 16 slots or 16 buckets will be allocated by default. Default capacity. Default will be 16 elements they say. You saw the document they are telling 16 elements, but actually technically if you say it is 16 buckets or slots. Okay, and as you fill 12 is inserted, again it will increase by 16. Clear this? Okay. So any type of keys you can add here, that's the advantage now. Any questions you have here? Okay, you should be good in hash table data structure. Okay, so for understanding all this, you have to study the hash table tables data structure properly, and then you'll understand this. But I recommend don't go and bother about those data structures. Okay, because they are very complicated. Java says do not worry about that. Just use the data structure. We are providing it for you. Why do you worry about all those data structures? This is how it behaves. Use it. That's all Java is telling. Understood? So do not go deeper into all this subject and try to understand all that, because data structures have a huge history of 70 to 80 years of history they have, and it's impossible for us to go and study those 70 to 80 years of history of all the data structures. Array structure, okay, linked list structure, they were not invented yesterday night and today night, okay, or it will be invented today night. Okay, they have their own history of inventions, so it is not possible for us to go and study. So just casually understand the behavior, start using it. That's all you have to bother. Done. Next, one more example we'll see. Yes, the same it is. We are seeing some more methods. That's it. You know now which are the methods? Contains key, contains value. Same, nothing else. So let's go one by one now. So is empty. First will be what? True. Then same methods what you saw for what? Tree map. Now it becomes very simple now. Size 0. I'll add some elements. Same I'm adding, nothing else. Same way it gets inserted. Then again map, what is that? Is empty will be false. Size will be 5 or whatever elements you added. Next, I am trying to use the same key. If I use same key, what happens? Ravi is there, Ravi is there. So what happens? This old value Ravi will be overwritten with what? 99.99. That's it. So earlier Ravi is saying what is the value? 22.22, no? So that will be overwritten with 99.99. Okay, so then again some more methods. See, after putting the values into the map, how do you get the values? I'm showing you how to do the CRUD operations. Inserting done. Next is what? Reading. How do you get it? Get. So use the key to get the value. Use the key to get the value. Automatically you'll get the value. Okay, but if the key is not there, value will be what? Null. Customer.get Tom. Tom key is not there now. So what will happen? The value will be null. Then next, if you want to delete, yes, you can delete this. Vinay will be deleted. This element only will be not there now. If I delete it now, I need this table. That's why I'm just maintaining it. Just understand this value will be deleted. Okay, but the 16 buckets will remain there. Only the element is deleted. Then next, contains key Ravi. Return type is boolean, true. Contains key Rama, false. Then contains value 33.33, true or false? False, because we are checking it in string style. But the same if I say 33.33 in double style, true. Means be careful when you are checking contains. Okay, you have to check with the same type. Okay, then next, clear. Yes, all the elements are deleted. Table will be, means hash table will be there, but the elements will be deleted. Clear? Yes, same thing what you saw with the tree map. Now we are seeing with hash map. Nothing difference. Hash map is empty, true. Before adding values, size is 0. After adding false, is empty is false. After adding the elements, number of elements are what? 5. Now I am printing all the elements. The next, value of Ravi means get I called now. Map.get. Look at this method, map.get. So what is it printing? Ravi. Then value of Tom, null. Okay, I deleted. Is there Vinay now? Vinay is not present. Then key Ravi is present, true. Key Rama is present, false. You get that now? 33.33 in double quotes, false. 33 new double of 33 means we are checking contains value. 33.33 is true. Value is in hash map after clearing. So this is how it works now. Getting it now, same methods. You're seeing the output there. One by one you can go on checking contains key and all that. Clear with this? Any questions? Okay. So done with HashMap. We'll now look how to iteration. That's it. If I show you iteration, almost all it is done. So I'll use, means here I'm trying to show you some more concepts. Iteration I'll show you. In this example I'm covering some more extra concepts. What I'm trying to say is, how do you put primitives into HashMap as key? How do you put primitives as HashMap into key? By boxing, means convert them to objects and put. So means simple. You cannot put primitives into map also. You have to put objects. Key also should be object, value also should be object. Understood? That's the concept. So always see the examples as concept. Okay, that is one concept. Then key can be of what? Any object. It's not that it should be string only. You can use integer, you can use double also as key. Okay, similarly value also can be what? Anything. But mandatory rule is key should be object, value should be object. That's it. Any key, any value. But again rule is there. If you're putting whatever keys you're putting, it should have what? The hash code method overridden. And luckily for us, integer also has having hash code method overridden. Okay, all the wrapper classes are also overriding what? Equals and hash code. All the wrapper classes string, they are overriding hash code and equals method. So we are pretty lucky, so we can directly use it now. Okay, so let's see now. When you say this, let's see how the hash table gets created. 16 spaces will be allocated, but I'll not write full because I need space here. Understood? So I say HashMap is equal to HashMap. What happens? This is how one hash table gets created. This is your hash table now. Your hash table will have what? Hash code and key. Okay. Yeah. So 16 buckets will be there here also. But I'm just drawing 4 or 5. Here also 16 will be there. Next, this is your map object. So once it is put here, new integer of 103. So for the integer class, which one? Hash code put method will execute what? Hash code method. Once it executes the hash code, it will get the hash code. So it will take that hash code and put it. Generally for 103, what will be the hash code? 103 itself. If I had shown you the source code, it will be returning the same value. Or you check it out. Integer x is equal to new integer of 103. X dot hash code. Return type is generally the same number. Okay. So they are doing it. So what is the key now? What is the key? 103. And what is the value? CCC. So this is the hash code. Understood? Now 105. Again. Key is 105. Again means the hash code method goes on getting executed. Then 102. That means it will be in random order. So this is how it has been stored now. But I am putting it consecutively. In the 16 buckets, you can put it anywhere based on their algorithm. We don't know, and so that's how it will be stored. Yeah. So just I'll print and show you. See, order is not guaranteed. You are storing it in some order, but it is means you are inserting in some order. It is storing in its own order. Understood? You are inserting in some order, but it is storing its node in its own order. Fine. So now, once you understand this, yes, we'll see how to iterate now. Map dot key set. What happens now? You get a collection of only keys. Which key? This key. In the same order you will get. Understood? So you are getting which object now? One set object. You will get one set object. and in the set object you'll have only what? Yeah. This is your set object, and you'll have only keys now. In the same order, 104, 101, 103, 102, 105, something like this. So I'm saying s dot iterator. So the iterator will be put to the before first. Now I'm iterating only through what now? Keys. I'm iterating only through keys. So I'm getting the collection of only keys now. So you know the method. So for getting collection of only keys, what should I do? This is iterator now. This is collection of keys. This is collection of keys now. Okay. This is a set object. For this set object I got the iterator. For getting the collection of keys, which method you should call? Key set method you have to call. So when you call the key set method, you get the collection of keys. Let's visit now. So I'm just printing the keys first here. Just see the output. I'll get only the keys. Yes, okay. We'll comment to this one. So that we'll not have confusion. That is SOP. That's it. So you're getting what? Only the keys. Yes. Now one more thing what you have to understanding is when you're iterating, you got the keys. Now using that key, yes, as you know, I can get the value also. That's your wish. How you use the key is your wish. Yes, so I'm saying map dot get of what? Okay, but do the typecasting properly. Okay, so you should be very careful while typecasting. You should know what is the type of key. If it is type of integer, typecast it to integer. If the value is type of integer, then typecast it to sorry, whatever the type of data it is, you have to typecast. Okay, if the key is of type integer, typecast it to integer. If the string, if the value is of type string, typecast it to string. That you have to do. Yes, now we'll see. So using the key, I'm retrieving the value. Done. Next. So this iteration key set is over. Next what? I can iterate only through values. Fine. So collection of values now. How will I get? So here you have got which object? Collection object. So for the collection object, what will I get? Iterator. Okay. So when I get it, so here what will happen means when you say map dot values, okay, you'll get only values D, A, C, B, E. Only values you'll get. Okay. And which method did I call now? Key. Sorry. Values I'm calling. Values is the method you're calling. So when you do that, you'll get the iterator. Where will it be pointing? Before first. So I'll start visiting now. Okay. As next, and I'll start printing all the values. So I can get a collection of only keys, or I can get a collection of only values. That's simple now. See, only values you are getting. Understood? But what is the method you are invoking? Map dot values. Okay. And you can check out the documents. If you're having any doubts, map dot, what are the methods I'm calling? Key set. What is the return type of key set? Set. Clearly it is telling you. Map dot values. Okay, see, map dot values. What is the return type? Collection. What is the big thing about this? Understood? So then again in collection, which method I'm calling? Iterate. C dot iterator. This is interface, you know, no? Collection interface. You already studied this. It's an interface. In that interface you got what? A method called as, if you want, click collection. So where it is taking you now in that collection, what are you having? Iterator. So I'm calling that. So when I say map dot values, I'll get the return type as collection. In collection I'm calling which method? Iterator. Simple. So you should know how to go on calling the methods. Java is all about calling methods. Nothing more here. You should know which method to call when. Yeah? So all logic is ready made. You just have to go on calling it now. So done. So I can iterate through collection of keys, or I can go through what? In clear now? See, this is how your hash, you have created your map object. Okay, with key as integer and value as strings. Okay. So now when you are iterating, you have got three options in maps. One is you can iterate only through keys. Other one is you can iterate through only values. The other one is there, which you can iterate through only, through both. Which one? Key and value. So for that, which method you'll call now? Entry set. Simple. So I call entry set. So this time you will have what? Key and value, that's it. 104 DDD, 101 AAA, 103 CCC, 102 BBB, 105 EEE. So which method will you call for this? Entry set. Return type is which object? Set object. For this set object, what will you get? Iterator. So the iterator will be pointing where? Before first. Has next. So what will you get? You will get an object of type what? Map.entry. So map.entry is an object which is having what? Both key and value. So entry is the inner class of map. Okay. So in map.entry there is a method called as getValue, getKey. So I can go on calling now. Okay. So we'll see this. Just a second. See, don't learn Java without document. It will be by hearting. I'm seriously telling you. Map.entry set. Return type is what? Set. Set dot. Sorry. Map dot. Which is the method I'm calling? Entry set. Map.entry set. Return type is what? Set. Fine. Then I'll get the iterator. First again, if you want, you can go to the document. Entry set. Return type is what? Set. Fine. In set, what am I getting? Iterator you can call. You'll get the iterator. Fine. So in the iterator, what you're telling now is has next. So it has moved now. Okay. So here you got what? Key and value, both you got. So fine. And I say itr.next, the return type of this is map.entry. So this is your map.entry object now. Both put together is called as what? Map.entry. Both put together, key and value. So there are two values now in that object. So how will I get it? me.getKey. Understood? So let's visit map.entry. What it is, we'll see. itr.next, typecast, you have to typecast it. So what is map.entry? Again you can go to the document. Map.entry. It is here. Map.entry. So public interface map.entry. Entry is the inner class of it. Okay, entry was released in 1.2. Okay, so in this, which is the method we are calling? GetKey, and the other method which you are calling is getValue. These two methods. If you want, you can replace the value also while iterating. While iterating, you can replace the value. That's your wish. But getKey and getValue. Generally, we don't change the keys. They're not giving an option to change the keys because they'll be coming from database, and it is not recommended you change the keys. But if you're interested, you can change the value. Okay. So they're giving an option. Replaces the value. That's it. So set value you can do it. Clear? So this is how you browse and go through, and then you have to code. It's all about patience. How much patience you have, that better you can write the code here. Okay, because here we don't write logic. See, one side is you have to write the logic. For writing the logic, it will take 1 day. Okay, for just if you have patience of 5 minutes, what happens? You can cover so many topics here. So one side you got the full story of writing logic. Other side you got just understanding it and using the logic. Understood? So which one would you prefer? Just with patience, if you wait, what happens? You can code more efficiently in Java. That's all. Okay, you don't have to write any logic here. So fine. So these are the methods we are using. Entry next. So I'm saying get key, it will give me what? Only key. Get value will give me only value. But typecast it. Get key again, get value typecast. You will receive the values. So this time I'm getting what? Both key and value. Done? Yes. So for this is what? Collection of. So there are 3 ways you can visit now. This is collection of key value. So when you are iterating through map, you have got 3 options. Whichever one you want, you can prefer. So if you want collection of key value, you call which method? Entry set. Entry set, for that you get the iterator. Iterator.next will give you what? Map.entry. Map.entry will give you key and value like this. Same with tree map. Same concept. So if you work in one subject, they have a uniform way with working with what? Everything here. Understood? Only the first one you have to put little effort. The second one becomes more easy for us. Only behind the scene what is changing now? The data structure. Yesterday we used tree map, today we are using what? Hash map. And you can see what flexibility you got here. Same concepts, okay, but only data structure is different, but you have a uniform way of working with both the maps, hash map and tree map. But behind the scene the data structure, you know how it's complicated. But on uniform approach, so we don't have to struggle here. In Java, that flexibility and plus they are giving you the luxury also. Means you put effort once and later on it will be very easy for you. That's what they are trying to say. Are you clear with these two diagrams now? So this diagram is for example 1 and 2. This diagram is for example 3. And if you wish, you can try iterating through that also. That's your wish. Yeah. So we learnt about hash map. Now, is hash map better or tree map better? Scenarios will decide. See, hash map has got very fast search rates. Understood? Hash map has got very fast search rates. Okay. Like example, see here. We called on method in the first example contains key. Yes or no? Or when I say, see this. When you say get, when you say map.get of Ravi, the hash code of Ravi will be taken. Immediately where it will reach? It will go to this hash code. It will find the key and it will get the value. So fast it is. So you have 1000 records, 10,000 records, irrespective. The hash code will be taken, straight away it goes to the bucket, gets the key, gives you the value. But in tree map what happens? The traversing time is more. It has to search many elements and then it will reach the key. Then from that key you will get the value. So to find the key only in tree map we lose time. But here finding the key is very very easy because your key is stored with the help of hash code. Understood? So search rate is excellent here. Okay. Then next, in tree map there is one advantage. What? The keys are stored in sorted order. So that's how you have to decide what you want. You want fast searches or you want sorting. Depending on that you can go on. But here order is not guaranteed. You can't guarantee the order. So that is one drawback here. You will not know the order. Understood now? Any questions here? There's some notes. HashMap notes you have seen. I'll do one thing I think. I think I'll cover the notes later because let me finish off LinkedHashMap because I'll use the same diagram now. Okay, then I'll give you the notes for HashMap and LinkedHashMap. Same example, nothing changed. Only what will be the difference now? The keys will be stored in the same order as inserted. Everything is same. So the keys will be linked with the help of double linked list. That's all. LinkedHashMap is the next what you are going now. I'll give you the differences. Just a second. We'll see all the examples. If you see the diagram now, we are going with what? LinkedHashMap, sub-interface of what? HashMap, almost all same. Only thing is the keys will be stored in the same order as inserted. That's all. Everything what you learned about HashMap is true. Same here. But only thing is the keys are stored in same order, insertion order we say. Understood now? But how it will be stored in insertion order? With the help of linking. I will show you, draw and show you the links, how it will be generating. Understood? So that's all. So first we'll see the behavior, then we'll talk about the diagrams, how it will be doing and all that. So I have done nothing here. Okay, and you can see the examples. This is in 10. HashMap examples where is in 10. The LinkedHashMap examples are in the project number 11. Okay. So in LinkedHashMap examples, I'm opening the each one. This package. In that I have got the first example. No change in the programs. Same program. No change in the programs. I can use the same table now. Understood? So here, let's take the first table now. Is it visible for you now? Okay, just manage because I'll be going, because I need this table also for what? Iteration. The same one I'll be using for iteration. See here, first which I am putting Kumar. So based on the hash code, same thing now. When you call put here also, what happens? Hash code will be taken for this string, and the hash code generated will be put into the hash code column, and the key will be put here now, Kumar. Okay, and for this key value, it will be attached like this. So first time fine. Next time Ravi. Now what happens? Again hash code method for Ravi will be invoked. Okay, so when hash code method for Ravi is invoked, what happens? It will be putting it here. But where is Ravi now? Here. But the thing is, both of them will be linked. These two keys will be linked now. Kumar and Ravi will be linked with help of double linked list. That's all the change. Understood? Next, I am adding Amog. So what happens? Ravi and Amog will be linked now. Where is Amog now? Here. So it will be linked. These two will be linked now with the help of double linked list. Understood? Then next, Vinay. Vinay will be linked now. With what? Amog. So don't make it complicated. Just understand the subject. Understood? So they will be linking with the help of double linked list. Now Vinay will be linked with Balaji. Then next Balaji will be linked with null. And next, so you'll be seeing all the elements in the same order as inserted. That's it. Even though they are stored in the hash table, but it will be stored in the same order as inserted. Means in the insertion order we say. Null. Then after that, integer and Praveen. Sorry, null should be linked with what? Integer. Where is integer? Here. Double linked list. Then integer with Praveen. Where is Praveen now? You're getting the idea now? So it will become too much crowded if I draw. Just get the idea. And diagram will look not look nice. Just get the idea now. So it will go on linking like this. So that's it. Very simple. So it will be using the combination of hash table data structure plus linked list to store the keys. So that's the reason your order is guaranteed. I added Kumar first, Ravi next, Amog next, Vinay next, Balaji next, null, same order. 10.10. Same thing, there's no difference. And some more concepts here. Yes, it continues. Can add null key in LinkedHashMap also. You can add null key here. You can add different type of key here. Understood? Then you can add different type of value here. You can add null value here. And at the same time you can add what? Duplicate value also. Same. Yeah? Yes. LinkedHashMap demo 2. So contains key, contains value. Get. These are the same methods. Second example. Contains key, contains value. Same methods now. See, a terrific data structure, and you're working it in a simple manner because we have one standard here. Understood? You're clear with all these methods now? Get. You can execute it. No problem. Same program, only behind the scene, your data structure has been changed. That's it. Now, iteration. Yes. LinkedHashMap. So we'll iterate through only keys first. See here I am adding in this order now. 103, 105, 102, 101. So your keys also will be in the same order now when you are iterating. 103, 105. But you are getting only collection of keys. Collection of keys. Similarly you can get collection of value. Similarly you can get collection of key and value. That's it. As simple. What is the difficulty here? So this is collection of keys. Next if you want you can go with collection of same subject, you get collection of keys, but in the same order as inserted. Okay, then you'll get here I think just change the order. 105, it will retrieve from there and put it in the same order, that's all. Collection of keys means, see, yes, only difference is here the keys will be like this now. 103, 105, 102, 101, 104. So that's what you are seeing here out. See, while storing it has stored like that only, randomly it has stored. But when it is getting the keys now, it is giving you in the same order as inserted. Yes, you can see the output here, 103, 105, 102, 101, 104. In what order you inserted the keys, same order you will get it. Clear? So obviously when your keys are like this, your values also will get in the same order, no? Yes or no? If you want, I will get only list of what? Collection of values. So values also I will get in the corresponding order. See, then this will be B, A and D. That's it. So I can get collection of only values also. Done. See, what is the first value? C, E, B. Compare A, B. The same. Done. Next, key value obviously will also be in the same order, no? So in what order inserted, change this diagram also. That's it. 103, B, change this also. That's it. So this is how it will be storing. This is how you will get the collection view. C, 105, E, 102, B. This is for linked asset I am saying. So linked asset. Then 101, A, 104, D. Earlier diagram was for hash set. This one is for linked asset. Sorry, hash map. We are talking about map. Clear? So when will you go for linked hash map? If you are really concerned about the order, understood? In what order you inserted, if you want it back in the same order, better you go for linked hash map. That's all. So option is there with you. Okay, if you want in the same order, go for linked hash map. And if you want in sorted order, you go for tree map. If you want in random order but fast searches, better you can go for hash map. Such excellent support is there from data structure. Data structure is giving that support. What is Java doing is, it is giving you more better support. It says, don't worry about that, we are given the implementation, just use it. Data structure is giving that support for you. So here you have to understand the data structure. Understood? But Java says, do not bother about implementing them, just use it from our library. That's what they are designed. So any questions you are here, ask. Else, it can, with experience, they have told you theoretically, as you go on coding throughout your life, same things you will be using, automatically all your doubts will be cleared also. Nothing to worry. These are just concepts what we are seeing here. Clear? And we have gone to the maximum depth. We have gone to the maximum depth, and gradually with practice, when you do projects, when you are coding, all your doubts will get eliminated. Because you have not seen the practical usage of this. So that's why here and there you might waver. Okay, something like this, something like that. But as soon as you start using it, you will get the complete grip of using all this. Done now? Yes, you have, okay, shall I clear this diagram now? Because I have to go with the notes, documents. We will see some of the constructors of HashMap. I think I showed you the constructors of HashMap. Almost all same they are. Okay. If you understand the constructors of HashMap, the constructor of LinkedHashMap also will be the same now. Okay. So I use the default constructor. Default constructor is 16 elements, and the capacity will be load factor will be 0.75. The load factor should always be between what? 0.0 and 1.0. Okay. So always remember we use the default constructor only. But still, for your knowledge purpose, I am telling you the other constructors. Always by default now, whether you are using hash set, linked hash set, we don't bother about all that. Just what you do, hash set HS is equal to, or set, hash set is equal to new hash set default. Linked hash set you want, linked hash set is equal to new linked hash set. Hash map you want, hash map is equal to new hash map. So generally we go with always the default constructor. But just if you want to really understand the document properly, I am giving you some information, like how you go through the documents. Yeah. So yes, again let's see now initial capacity. If you want to reduce the capacity instead of 16 to 25, 30, 45, more or less also 8, something like that, you can use this. But again the load factor will be what? 0.75 only. And you have to add that F. If at all you really want to use, you add 0.25 F. The next, initial capacity, load factor, both you can give now. Okay, initial capacity is 8, load factor you can give what? 0.9, you can increase it like that. And okay, can you guess this? What is this? Hash map means from tree map. If you have got elements in tree map, I can put that into hash map. Simple. Supposingly say I have got the tree map. Tree map TM or sorry map is equal to new tree map. Map dot put. We'll put all the elements. New integer of 10 comma string is a, something like this. Now this tree map, what I do? Hash map is equal to new hash map of map. That flexible it is. From tree map you can put to hash map, from hash map you can put to tree map, or you can put it even to linked hash map. What means from one data structure you are copying all elements into what? Other structure. Imagine 1000 records you are having primary memory, and you are just playing around with data structures. That luxury you are getting here. So don't see only 2 values, 3 values. Okay, what is so great about it? You'll be having thousands of records, and like that you can transfer from one location to other location. Understood? So that is the beauty of all this. Yeah? See how many ever words you use to what? Boast Java. It is less only. Okay, the language is like that because of its library. Language is very small here. 25 days, 30 days, language is over. The day you complete packages, okay, your language is over here. After that, it's all about studying library in Java. It is one of the easiest language on earth. For other languages, how many days you take? For studying the language only, you'll take around 6 months, 8 months. Like example C, full get the grip of C, will take 8 months. Because single pointer, double pointer, triple pointer will start off. So here nothing of all that. We just understand what is the language, what are the data types, finished, over, packages. And then only we study the library. We don't bother about writing the logic also. That is the luxury you get in Java. Clear this? So these are the things. And now if you want, you can go with what? Linked hash map also. Same constructors. It's a subclass. Click. Yeah. Same constructors. No difference. One more is there, access order. You can define some order here. Leave all that. Okay. So then that's how you can use this library. Yeah. So these are the different members of the class. You remember what I was teaching in core Java? What was I teaching you? Members of the class. Today also what am I teaching you? Members of the class. I used to give notes. We should always study the members like this. Okay, that time you are feeling what's so big thing about a member? Now what are you studying? Members of the class only. So I thought core Java from accurately library point of view, accurately from project point of view only. What is required, that is what I pitched in. Clear? Okay. So all this you'll understand when you start working slowly, how I pitched core Java for you. Clear? Fine. Next, come to the documents. When I was teaching you members of the class, it was boring now in core Java. Yes or no? What member? M1 method, M2 method. Now you see members. Nothing we do. You just create objects and work with the members. Yes, to start with HashMap now, notes I covered, I think. Yes? These notes has been covered. Then next, LinkedHashMap. Almost all same. Key value pair stores the key in hash table data structure and links them with double linked list. Keys will be stored in the insertion order and are unsorted. It is unsorted and it will be stored in the same order as inserted. Null keys and null values both are allowed here. Different type of keys and values are allowed. Duplicate key values are allowed. LinkedHashMap is not synchronized. Differences we'll see. Yeah, first we'll start off with difference between HashMap and tree map. Yeah. So HashMap uses hash table data structure to store seed keys. Tree map uses what? Tree map data structure to store its keys. Keys are unsorted, their keys are sorted. Different type of keys elements are allowed. Only similar type of key elements are allowed. Null keys are allowed, but in tree map, null key is not allowed. Remember that. It provides very fast search rate. It is relatively slow. I'm not saying slow. Compared to HashMap, it is slow. Okay, and then these are the similarities. Both are used to store key value pair. Both do not allow duplicate keys. Both allow null values. Both allow duplicate values. Both are not synchronized. Both are eligible for cloning and serialization. Both can use only iterator, but not list iterator and enumeration. Almost all. Now we're comparing HashMap with LinkedHashMap. HashMap stores elements in hash table. LinkedHashMap stores elements in hash table and links them with double linked list. The keys are unordered or undefined in HashMap, but the keys will be stored in the insertion order and are unsorted. Okay. More things, similarities. Both are used to store what? Key value pair. Both do not allow duplicate keys. Both allow dissimilar keys. Both allow null keys, null values, duplicate values. They allow. Yes, this is important point. The key elements which are used as key must have overridden hash code and equals method. That is mandatory for both. Understood? HashMap also, LinkedHashMap also. Both are not synchronized. Both are eligible for cloning and serialization. Both can use only iterate. Okay, that's it.